Good morning. Welcome to another lesson of Math 8. Today we're working on Unit 3, Lesson 8, talking about translating of y equals mx plus b. In this case, what we're talking about is making more of a transition to this equation or this formula for linear equations. So today let's see what happens when the equations are translated. Remember that translation is talking about moving an object without turning it. So we slide that object either left or right, up and down. Remember the translation? We never ever change the angles. We never change the size. So as we go through this, keep that in mind as we go ahead and start translating some lines. In this diagram, you see several lines. You see only part of the lines, but they're actually continuing on forever in both directions. So these lines, at some point, they may cross other lines. They may not. It all depends on some things that we've been talking about. So let's think about this for a minute. Which lines are images of line F under a translation? Well, we've been talking about a couple of different pieces in the past about angle measures. In this case of lines, since there's only one line, there's not multiple sides, we need to consider the slope of the line. The other thing we can do with that and that slope of the line is we can start looking at just the distance between the lines, or the vertical distance between the lines. Taking a look from this point right here, let's go ahead and look between the two lines right here. The distance between these two lines, if I was to look from F to H, is going to be 1, 2, 3, 4, 5, 6 units up from that line. Now the question is, will this stand true in all of the different places where these two lines are away from each other? The easiest way to tell that is to go ahead and compare their slopes. We want to look here. Let's find a couple nice integer points. Here's one right here, and here's another one right here. So let's go ahead and find this. This is a rise of 1, 2, 3, and a run of 1, 2, 3, 4. So we see that J has a slope of 3/4. Now, if H is parallel, it will have the same slope. So we go 1, taking from right here to here. We have 1, 2, 3, 1, 2, 3, 4. Awesome. So I know that H is definitely parallel. I'm going to go ahead and use I'll go ahead and mark that one with the same color highlighter to make sure we see that this is the same line. Excuse me, not the same line, a parallel line. And I know it's parallel because it has the same slope. Under translation, the angle measure can't change. I look at G. Clearly, G can't work because G intersects with line F. We see that J also intersects at that same point, and at a completely different angle. It comes down at a negative angle. But what about letter I? Letter I is kind of cool because I can actually look at it from several different places. I can take a look from the same intersection right here and see that letter I is down 2 units. Then I come up here at this other point and I see it's down 2 units away again. I come up 3/4 again, and I see that it's down. I have 3 separate points that show that we have a translation of 2 units down, which tells me that this line has the exact same slope as well. Just to verify, we can take these 3 points that we found and see that we have a rise of 1, 2, 3, run of 1, 2, 3, 4. Rise 1, 2, 3, run 1, 2, 3, 4. We see that that slope of 3/4 is consistent all the way through line I. So for these translations that we're after with this, the reason I drew those lines on there is because it told me to down here, number 2. I'm sorry I didn't show you that. But for each line that is a translation of F, draw an arrow on the grid that shows the vertical translation distance. So when we talk about this line H, we would say, since we're translating up, we're translating that y coordinate, we would just say up 6 units. Let me double check that. 1, 2, 3, 4, 5. Yep, 6. And then line F, we translated down 2 units. And you'll notice what I did here is I did a +6 and I did a -2. That's going to come in handy here in a little bit when we go to work on this. All right, this next question has an interactive digital version. So if you wanted to go ahead and use that link, go for it. You can do this digitally. Here on the packet, we'll go ahead and do this by hand. This is talking about a situation where Diego is babysitting, and we're talking about assuming that he has no money before then no money saved before he started babysitting and plans to save all of his earnings. Graph how much money Y, well, that's an important piece, how much money is Y he had after X hours of babysitting. So we see the blank coordinate plane up above, and we can go ahead and start working with that. If he had no money, that means that Diego started here, 0 hours of babysitting, $0 saved. After 1 hour of babysitting, he earned $10. And after 2 hours, he would have earned 20. 3 hours, he would have been earning 30. 4 hours, 40. And you can see the pattern beginning to continue. Now, imagine, actually this one can have a line because this is money over time and he gets paid for all that time that he babysits. So we can go ahead and draw that line. Now imagine that Diego has started with $30. How does that change the situation? Well, if he started with $30 and we're working on the same axes, we're graphing the same, working with the same money, the same slope, everything there, he's still earning $10 per hour. Then we need to consider that piece of that the money saved starts right here at $30 is where he begins, but then we're working at the same rate. So for 1 hour, he's going to earn $10. And after 2 hours, he would have earned another $10. And after 3 hours, another $10. 4 hours, another $10. You start to see the pattern going up here. And we need to compare these two lines. Let's get this line drawn on here nice and straight with the ruler. Compare the second line with the first line. How much more money does Diego have after 1 hour babysitting, 2 hours of babysitting, 5 hours, X hours? When we think about that, in both lines, let's say that this is like line A and line B. We'll go ahead and label these. We'll call this one B, this one A. What we see in line B is we see that there's an increase right here of $30. So after 1 hour, we see that there's $10 and then there's $40. So 110 versus 140. There's a difference of there's a difference of $30. If we look at 2 hours, we're looking at 2 and 20 for the ordered pair compared to 2 and 50. Well, again, difference of $30. We can see that just based on what we did up here in the graph, like what we did in the previous ones talking about that translation. We see that this is directly 30 units above every single hour, which indicates that he's made $30 more every single hour. So what we can say with that is after any number of hours, he's always going to have $30 more than he did before. So when we write an equation for this line, we can take a look and see what kind of information it is that this will demonstrate. If he started with $0 and he was making $10 per hour, then here's his equation for graph A. Graph B was a little bit different. The total amount of money that he made was equal to the $30 he already started with, and then he was adding $10. I'm doing horrible at showing this stuff. And he started with the $30, and then he was adding $10 every single hour. Or we could say that the same equation would look like this. Y is equal to $10 an hour plus the $30 that he already started out with. Okay. This graph shows two lines. Line A goes through the origin 0, 0. Line H is the image of a line under translation. Select all of the equations whose graphs is of line H. So we need to look here at line H. What we've been working with here is talking about what's actually happening here between the two lines. I think it would be helpful to think back to what we've done before with regard to the lines when we talked about a direct variation. We're talking about a constant of proportionality from 0, 0. We see that from right here at the origin, we rise 1 and run 4. So this line, line A, has a slope of 1/4. Line H, we see the same thing. We see a slope of rise 1, run 4. Rise 1, run 4. Rise 1. constant rate. So we see that these two lines, they must be parallel because they have the same slope. Now, one of the key things that we talked about today is we talked about the translation of those two lines. Since this one had a slope of 1/4, the equation would just simply be y equals 1/4 x. This equation would start out the same way for line H, y equals 1/4 x, but there's one major difference. This line does not pass through the origin. Instead, it is 5 units down from the previous line at all places because we know the lines are parallel. By understanding that these two lines are down 5 units, we can talk about that translation, that my line, y equals 1/4 x, has been translated down 5 units. Now what we need to do with that is we need to recognize a couple things. We found out that the slope is 1/4. But then we have this other thing that we talked about right here, this other point. This point we brought in briefly was the vertical intercept, or what we call the y-intercept. In this case, the y-intercept, the line crosses the y-axis at the ordered pair of 0, -5. What we see in our formula here, we talked about this y equals m times x plus b. What we see right here is we have m right here, which is our slope. But then we also have this other line here called, or this other value here called b, which is our y-intercept. So all we need to do is we need to recognize now, going over to these other lines, these options here, select all the equations whose graph is line H. So we can quickly just go through here and check to see what is the slope, making sure that we're all in some form of y equals m times x plus b. So I see y, I see x on opposite sides. I see the coefficient of x is 1/4 and a -5. This must be one of those solutions, or one of the equations. In part B, I see a slope of 1/4 and a y-intercept of +5. Well, +5 would actually be way up here. So we can't choose item B. That one's out. On letter C, looks like they tried to trick us and put the y over here on the right. Y equals 1/4 of x minus 5. That's the exact same equation as A, just with A or y in another spot. Letter D looks like they did some more rearranging, but we see a -5 as a constant, just like we see right here, a constant, and a 1/4 as the coefficient of x. Letter D also represents the line. Let's look at the next one. -5 is a constant. 1/4 x is our coefficient of x for our slope equals y. That one's also okay. Letter F, we see a +5. Oh, but again, the problem with that +5 means that that line is actually translated 5 units above, and we see this as a -1/4 x, which would mean that the slope is negative or going down to the right, which won't work. So just picking those out, again, the most important things that we're looking for is this right here, the slope and the value of the y-intercept. To wrap it up, there is one activity that you're going to do on Desmos. You have 12 cards. Actually, there's 11 cards because one of them is blank. But there's 11 cards that's in a Desmos activity, and you'll be doing a card sort with these cards. So just take each of these here with your graph, pull out the graph, and you're supposed to find out which one of these descriptions, which one of the equations, which one of the tables, just match them all up together. And what you'll end up having by the time you're done is you'll have 4 groupings. So this is in no way the way that these things are matched up, but we would put one with this one, and you see it drops it with the card sort, just like what we've done before. But I will tell you right now, this one does not go with this line right here or with this graph right here, because in this graph, we see that the line is intersecting at 1 or at 0, 0. So the y-intercept is at 1. And in this equation right here, the y-intercept is 3/2. So we can't have that one going to this one because this is not the same slope as what we saw in the graph. So match them all up there, do a great job, and then you're on your way to finishing the lesson. Summary for the lesson: during an early winter storm, there's a situation that talks about a storm with 1/2 inch of snow each hour. We can see the rate of change is 1/2 hour in both the equation, or in the equation right here, it represents y equals 1/2 of x, and the slope of the line representing the storm. So we see right here the depth of the snow is 1 inch for every 2 hours. important to recognize that that rate of change is there. During the winter storm or the midwinter storm, the snow fell again at a rate of half an inch per hour, but this time there was already 5 inches on the ground. Well, then the next graph that we see, the next logical thing that we would see is the exact same line from previous, but then we would just translate that 5 units up. Think about the snow line or the ground level is right here. It snowed 5 inches. And so on top of that snow, we would have the exact same rate of change coming off, but we would see it from a level that's 5 inches higher off the ground. So we can use all that information to find a lot of different values. After 2 hours, now all of a sudden there's 6 inches of snow, total inches of snow. After 4 hours, there's a total of 7 inches of snow. A lot of different things we can gather from that after using the 2 lines. That's it for today. Make sure to do your homework following this. You're doing a great job. Let me know if you have any questions, and don't you dare give up.